Good evening, everyone, and welcome to York's Observatory's TeleTube, the online astronomy and astrophysics program, ran and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Illinois Carswell Observatory, located at York University, Toronto, Ontario, Canada. TeleTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions, comments, or if you have any suggestions for past shows, please send us an email at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle York Observatory and Facebook at Alan I. Carswell Ops. I'm Obada, and I'll be one of your hosts this evening, along with Manny, Arfa, Dhyan, Maheen, and Matt. Tonight we have an awesome presentation about the Orion Constellation. But before we get started with our main show, we want to give you a little update on what you can see this coming week. Unfortunately, because of the alignment of the constellations, Orion appears to be currently positioned in the sky right next to the sun, making it practically impossible to see. However, there are still some interesting astronomical objects you could see tonight. In Toronto, right after sunset, at around 9:30 p.m., you could easily catch our neighboring planet, Mars, low in the western horizon. If you decide to stay up, Saturn and Jupiter will also appear next to each other in the sky at around 2 a.m. Remember, Jupiter always appears to be the brightest of the two planets. Shortly after, the waning moon will be rising in the east. Now remember, in a little over a week, the moon will line up in such a way to form the annual solar eclipse in parts of northern Ontario. Here in Toronto, you can also see the eclipse with about 50 to 60% coverage of the sun during next Thursday morning. Please check out next week's TeleTube for a special event on this eclipse. Or for more information, visit our website, observatory.info.urq.ca. We hope to see you there. Now, without further ado, let's get started. Manny will start us off tonight with an introduction to the Orion Constellation.
Constellations are one of the earliest forms of astronomy. As our ancestors gazed up towards the stars with curiosity, they started to pick out and name distinguishable patterns among the stars. Today, these patterns are known as star constellations, and they are studied in astronomy all around the world. Constellations are very useful to amateur astronomers since they offer visible guides to help you navigate through the night sky and find objects that you wish to observe. The Orion constellation is one of the earliest known constellations because of its easily identifiable pattern. The earliest known record of the constellation is a mammoth ivory carving found in a cave in Germany. The carving is estimated to be around 32,000 to 38,000 years old. From then on, the constellation has been widely seen in many different cultures around the world, with each culture having a slightly different interpretation of the constellation. The name, the name of the Orion constellation comes from its Greek interpretation. In Greek mythology, the Orion is a skilled and strong hunter, and since the constellation resembles the shape of a hunter, it's named after Orion. The constellation is also significant in many other ancient and modern cultures. The indigenous people of North America have observed the night skies for a long time, and over time they have developed their own astronomy. The Orion constellation has many different interpretations among the North American indigenous people. Some cultures use the constellation for nightly timekeeping and calendar functions. According to a Harvard University article by Frank Dempsey, the Navajo people started planting their crops when the constellation set at dusk, which happens around early May. In one of the mythologies from the native Cree people of subarctic Canada, the three belt stars are the prominent stars of the constellations, and the name of the constellation roughly translates to the three chiefs. The Arctic Inuits also have many different interpretations for the constellation. One of their main interpretations sees the three belt stars as the three hunters and their fainter stars underneath them as the hunter's children. The Orion Nebula is also seen as a fur being carried by one of the children of the hunters. According to another According to another article by University of Toronto written by Hannah James, in one of the main Ojibwe interpretations of the constellation is seen as two brothers, one representing the cold wind and one representing the warm wind. The two brothers are wrestling and in a race to one star, and the brother that represents the warm wind seems to be winning. To more to see more about Ojibwe constellations, check out the map on skywatchers.com that is seen on the left of this slide. You can also purchase the map from the website for some fun stargazing. Also from Harvard, an article by J. Rogers, the ancient Babylonians also cataloged this constellation in late Bronze Ages, and their name for the constellation roughly translates to heavenly shepherd. The constellation also has many significant roles in ancient Egyptian mythology. One of the Chinese names for the constellation roughly translates to the number 3, which is due to the fact that the constellation has 3 significant stars in its belt. We could likely have a whole episode about the Chinese constellations, which are seen in this beautiful engraving in the right. It is also fascinating and in the educational to look at the different interpretations of constellations in different cultures, as they can teach us about how astronomy has developed differently in many different cultures around the globe. The Orion constellation is one of the most used constellations in the skies, thanks to the fact that it is very visible and easy to spot. If you live around Toronto, the constellation is best visible during the months of November to February in the southern western sky. So unfortunately, we have to wait till November to observe the constellation again. Locating the constellation is relatively simple. One of the easiest methods is to look for 3 bright stars in a row. If you spot these, you are probably looking at the Orion belt. To be absolutely certain you're looking at the Orion constellation, you should look at the diagonals of this belt, and you should be able to see 2 brighter stars on both sides, one being slightly red and one being slightly blue. Let's take a look at the individual parts that make up the Orion constellation. The Orion constellation is usually divided up into several parts. The belt of the Orion is one of the best known parts of the constellation. It consists of 3 equally bright stars in a straight line. Another beautiful feature of the constellation is the Orion sword. The sword contains some breathtakingly beautiful nebulas, notably the Orion's Nebula. The head of Orion is a triangle shape formed from 3 stars, the brightest of which being Messiah. Orion's club is another noticeable feature of the constellation. It starts at an easily identifiable star called the Betelgeuse, and it consists of 5 other stars that together make up the elbow and the club of Orion. Last but not least is the Orion Shield, which is made up of 6 Pi Orionis stars. Also, as you can see in this very cool GIF, the constellation is not always the same shape. The shape of the constellation has been and will be changing over time because of the proper motion of the individual stars that make up the constellation. Now I will hand his belt.
Thank you, Manny. So let's start talking about the 3 stars, or also known as the 3 kings. In South America and Portugal, the 3 stars are known as Las Tres Marias and as Três Marias in Portuguese. Starting from the right side, there is Mintaka. Special shout out to Dhyan, our new team member who created this amazing slide with some amazing facts. So Mintaka is a supergiant star that is about 900 light years from Earth. Mintaka is actually a double star system, and the 2 stars orbit each other every 5.73 days. The name Mintaka is actually derived from the Arabic word al-Mintaka, which means the belt. Mintaka is about 7,000 times brighter than our own sun, and also, unsurprisingly, much more massive than our own sun, about 20 times more massive. The surface of this bright white blue star is about 60,000 degrees Fahrenheit, or about 33,315 degrees Celsius. Just for comparison, the surface temperature of our bright yellow sun is only about 5,505 degrees Celsius. Mintaka's age is still a mystery to us, but we do know that Mintaka is part of the Orion complex. The Orion complex is a huge star forming complex consisted of nebulae, dark clouds, and young star clusters. We also know that the Orion complex only ranges up to stars that are at most 12 million years old. So we know that Mintaka could not have formed more than 12 million years ago. So it's a comparatively young star system. An interesting fact about this binary system is that it is the closest binary star to us. Another interesting fact is that Mintaka is the 7th brightest star part of the Orion constellation. Mintaka is massive enough to one day explode into a beautiful supernova. But as of now, it is too young and will take millions of years for that to happen. That's all we have on Mintaka, the beautiful double star. Moving on to the next major star part of the Orion belt is bright blue supergiant Alnilam, about 1,975.8 light years from Earth. The central star of Orion's belt is the brightest of all three stars, despite being the most distant. Also, it is the only single star of the three. The name Alnilam comes from the Arabic word al-Nizam or al-Nazm, meaning the string of pearls. The fourth brightest star of the Orion and 29th brightest star in the sky has an average magnitude of 1.69. The physical properties are still uncertain. This star has been classified as an Alpha Cygni type variable. Alpha Cygni stars are basically supergiants. It changes in brightness from magnitude 1.64 to 1.74. Alpha Cygni stars are supergiants with the spectral classification B or A that exhibit changes in brightness as a result of non-radial pulsations, with some portions of their surface contracting while others simultaneously expand. Alnilam's estimated luminosity ranges 2,75,000 and 8,32,000 times of the sun. The middle star of the Orion belt appears to be bluish or blue-white in color, being a spectral type of B01A. This star is 40 times more massive than the sun, with a radius of 32.4 times solar radius. Alnilam's stellar winds reach up to 2,000 kilometers per second, which results in the star losing mass at a 20 million times greater than the sun. Now the easternmost star of the Orion belt, Alnitak, Zeta Orionis. The traditional name Alnitak, alternately spelled Alnitak or Alneta, is taken from the word Alnitak, the girdle. Zeta Orionis is a triple star system with a combined apparent magnitude of 1.77. It lies at an approximate distance of 1,260 light years from Earth in the constellation, ranking to be the fifth brightest star in Orion and 31st brightest star in the sky, sharing its place with few other stars, like Alliot, the brightest star in the Ursa Major. The three components consist of Altenac A, which itself is a binary star. Altenac A has two components, Altenac A, the primary star in the Zeta Orionis system. It's a hot blue supergiant with stellar constellation O9.5 IAB. Actually, it's the brightest star class O star in the sky. The star has a visual magnitude of 2.0 and an absolute magnitude of minus 6.0. It has 33 times the sun's mass and a radius 20 times that of the sun. Although star AB is a relatively young star of about only 6.4 million years of age, it has already stopped fusing hydrogen in its core, which means that it will evolve into a red supergiant before ending its life in a supernova explosion. The other component of Altenac A is Altenac AB, a super subgiant star which has been classified spectral classification of B1IV. It has an apparent magnitude of 4.28 and an absolute magnitude of minus 3.9. It lies only 11 astronomical units from the primary star, which makes the pair a very close binary system. To illustrate, the distance from Sun to Saturn is about 9.58 astronomical units. The third star of the Zeta origins is Altenac B, a class B giant star with a visual magnitude of 4.01. It orbits Altenac A every 1,508.6 years. Unlike Altenac AB, which can be only detected spectroscopically and informatrically, Altenac B can be resolved. A fourth star, Altenac C, can be seen in the vicinity of the system, but it is uncertain whether it is gravitationally bound to it or merely lies in the same line of sight. So these three stars make up the Orion belt. Other stars in the constellation include Hatzia, which establishes the tip of Orion's sword that hangs off the belt, and Mesa, which forms Orion's head. Safe serves as Orion's right knee. Rigel, Orion's brightest star, forms the hunter's left knee. Now Maheen will tell us more about the Betelgeuse.
Thank you, Arfa. I will now be talking about Betelgeuse, which is an important part of the constellation Orion, which is our topic of discussion. Betelgeuse, also known as Alpha Orionis, is the second brightest star in the constellation Orion. It marks the eastern shoulder of the Hunter, which the constellation is perceived as. It is considered to be one of the most luminous stars in the sky with an apparent magnitude of 0.6. But in the late 2019, it began dimming, resulting in an apparent magnitude of 1.6 in the early 2020. It is easy to spot due to its brightness, position in the constellation, and deep reddish color, and is at a distance of 640 light-years from Earth. It is a red supergiant star and thus 950 times as large as the Sun. A good comparison for this is that the diameter of the Mars's orbit around the Sun is 328 times the Sun's diameter. Betelgeuse is believed to have originated from an O-type main sequence star. As mentioned before, it is a red supergiant star, which means that it is an aging star which has consumed most of its supply of hydrogen and fuel from its core. Theory suggests that Betelgeuse formed 10 million years ago from dust, gas, and gravitational pull, and molecular clouds in the Orion played an important role in its formation. It has quite a young age for a star. Since 1993, the star has become smaller. It is constantly losing mass, about one solar mass every 10,000 years. This lost mass is engulfing the star. Some parts of the mass have been blown off into the space due to powerful solar winds reaching up to more than 30,000 astronomical units away from Betelgeuse. Because of its mass, Betelgeuse has a density less than that of air. It has a surface temperature of 3,500 Kelvin, which is 60% as hot as the Sun. Its rotation period is believed to be 15 to 30 years. It travels at a supersonic speed of 30 km per hour. Its stellar wind creates a bow shock and ejects vast amounts of gas into the interstellar medium at a speed of 17 km per hour, causing the material surrounding the star to heat up. Since Betelgeuse is the nearest red supergiant star, it is destined to explode as a supernova. As discussed before, dimming of the star was observed in the late 2019, which to some suggested that the supernova is near. However, no explosion has yet occurred. The star has not only dimmed but brightened itself again and repeated the cycle several times. Astronomers have explained the dimming of the star to be the result of a dark cloud blocking the star, since an outflow from the star was detected by Hubble before the strange observation. Whenever the supernova happens, Betelgeuse will brighten enormously for a few weeks or months, making it visible in the broad daylight. There is no exact answer to the question, when will Betelgeuse explode? It can explode tomorrow or maybe in a million years. No one is exactly sure. In case it does explode tomorrow, it might be a concern whether it would harm us, that is, the Earth. Well, not exactly. We are too far away to be affected. In order for it to harm us, we would have to be within 50 light years of the supernova. So there's nothing to worry about. Rather, it will be a beautiful sight in the night sky in the form of an extremely bright star when this event actually happens. Betelgeuse is famous among amateur astronomers not only due to its size and brightness, but also because it is a part of the constellation Orion. Astronomers keep a close eye on it due to its variable nature. The diameter changes anywhere from between 550 to 920 times the Sun's diameter. Another interesting event that the star will experience is its crash into the wall of interstellar dust in the next few thousand years, but before the supernova explosion. While some theories suggested that the interstellar dust was due to the matter ejected in the previous stage of the star's evolution, it was later discovered that it is a separate object, either a linear filament linked to the galaxy's magnetic fields or the edge of a nearby interstellar cloud illuminated by Betelgeuse. In 2013, it was suggested that it would crash into the dust at a speed of 107,761 kilometers per hour, which will take a while to complete. Solar wind is expected to touch the line 5,000 years from now, with the heart of the star crashing into the bar 12,500 years after that. We still have much to learn about the star. I will now hand it over to Matt to tell you all about nebulae in the constellation.
Thank you, Maheen, for letting us know about this very interesting information. We know now that the Orion Constellation is extremely beautiful and packed with amazing astronomical objects, not only stars forming in shape, but also nebulae that light up the sky in a way that only a nebula can. There are several nebulae located in the Orion constellation, and as you may remember from our nebulae teletube, there are different types of nebulae depending on their composition and temperature. We can have the emission nebulae as well as the reflection nebulae, the planetary nebulae, the trifid, and the dark nebulae. And as a matter of fact, we have many different nebulae located in the constellation of Orion, being an example of this immense variety. The first one is, for obvious reasons, the Orion Nebula. The second one I will be mentioning tonight is another one of the famous nebulae located in Orion, which is the Horsehead Nebula. And then we also have the Witchhead Nebula, which is an emission nebula, and the Flame Nebula. Let's start with this one. The Orion Nebula, or as we commonly know it in astronomy, and specifically as part of the Messier catalog, Messier 42, is one of the brightest nebula in the night sky, and it is located on at only a mere 1,500 light years away from us, making it the closest star forming region to Earth and causing it to appear so bright from our point of view, with an outstanding apparent magnitude of 4 and a diameter of 30 to 40 light years, making it visible to the naked eye. Located just below the Orion's belt, to be more specific, between Betelgeuse and Rigel, the Orion Nebula has been important for many ancient civilizations, such as the Mayans, who saw it as a consequence of a big cosmic fire. And indeed, this diffuse nebula not only looks amazing in all its gaseous glory, but it looks like it is made up of fire, with four main stars which can be seen by amateur astronomers, and they are the ones in charge of illuminating the whole Orion Nebula, forming, we could say, a mini constellation inside the Orion Nebula, commonly known as the trapezium. And let's not forget that the first official nebula ever to be identified was indeed the Orion Nebula in 1610 by the French astronomer Presque. Now, as I mentioned before, this is not the only mind-blowing nebula there is in the Orion constellation, because we can also find the famously shaped Horsehead Nebula here as well. Located just below Alnitak, we can find the Horsehead Nebula or Barnard 33, a nebula that is amazing not only due to the colors we see in it, but more because of its shape and its uncanny similarity to a horse's head. Now, if you don't remember what a dark nebula is, well, they are basically interstellar clouds, as we can see in the image, that contain a very high concentration of dust, absorbing and scattering all incident optical light coming from regions of high star concentration and making them opaque at visible wavelengths. Now, a star formation also takes place in this nebulae due to its temperature and its high concentration of hydrogen molecules. This nebula was first described by the astronomer Edward Barnard and then was first recorded in 1888 by the astronomer Williamina Fleming at Harvard College's observatory. This, as a matter of fact, wasn't the only nebula to be found in Orion that looks like it has the shape of something else. This eerie and mysterious nebula we can see right now is the Witchhead Nebula, named due to its resemblance with a witch. The Witchhead Nebula, or IC 2118, is a reflection nebula located near Rigel and reflecting its light, just like its type of nebula suggests. Now, if you didn't know or just didn't remember what a reflection nebula is, well, it consists of, again, interstellar clouds, as we can see, made up of dust that in this case reflect the blue light coming from a nearby star, which is in this case Rigel. Many astronomers believe that this nebula is the old remnant of a supernova, and it was first noted by the German astronomer Max Wolf in 1909, and then officially identified by Edwin Hubble and named Witchhead Nebula by the astronomer Frank Ross in 1927. Last but not least, another beautiful and fire-looking nebula is the Flame Nebula, or NGC 2024. Located at just 1,400 light years away from Earth, this emission nebula shines due to the light coming from the star Alnitak, which, as was mentioned before, it is one of the Orion's belt stars and part of the Orion molecular cloud complex, which consists of several regions of interstellar dust and gas clouds, such as the Flame Nebula itself and the Horsehead Nebula that was mentioned before. This nebula is also a region of star formation due to its composition and its richness in hydrogen gas and high temperature, making it have a cluster of newly formed stars in its center and all their stars in its surroundings, which NASA is actually studying in order to understand more about the star formation process and try to figure out why and how are all their stars drifting away from the center of the nebula and giving space to new stars, forming circumstellar disks in 86% of them. But for the time being, let's just enjoy this majestic nebula as it is right now, and remember that all of this is part of the Orion constellation, something that we can find in the night sky almost every night, and yet we can't realize how big and beautiful it actually is. And well, everyone, you have been listening to the Alan Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Obada, Manny, Arfa, Dhyan, Maheen, and myself, Matt. Make sure to leave any questions or comments in the comment section of the video and talk to us in the chat right now. We will be around for the next 20 minutes to answer your questions. And as you may know, all of our programs are free, but if you would like to make a donation or even buy one of our wonderful astrophotography calendars, which by the way, they are now 50% off. Yes, you heard me right, 50% off at the bookstore. You can see our website at observatory.info.urq.ca to find this and much more. You can always connect with us on Twitter with the handle at York Observatory and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in. Clear skies and have a good night.